Okay, hi guys, and welcome to our first webinar for 2016. So I hope that you had a really great time and a lot of fun during the Christmas break. Tonight we're going to have Mark. I met him during the Full Stack conference in London a few months ago. I was really impressed about his speaker skills and also about GANDB. So it's, the mind behind GANDB is a NoSQL database, a graph database, I would say. Correct me if I'm wrong. Good. And I'm pretty sure that tonight he will show us a lot of great stuff around that, and I hope that you will enjoy it. If you have any question for Mark during the presentation, feel free to send all the questions on Twitter with the hashtag LondonJS, and I will review them, and at the end of the session we will ask everything to Mark. So if you have any question, again, use Twitter. I'm pretty sure that you will enjoy this session. Mark, mate, it's up to you, and I hope you will enjoy your time here.
Thanks. Hi, I'm Mark Nadal. I'm the founder of Gun. We're a funded startup, and we make the open source JavaScript database Gun. Now, before we dive into some code stuff, I first want to switch over to screen share and show you an outline for the talk, so that way you know what's going to be going down. All right. So we're going to be first going over what Gun is and how you can use it. So I'm just going to show you what it is. Second, why I built it that way, the decisions that I made. 3, we're going to do some programming with graphs, explore what that looks like. 4, probably a good question out there is, aren't there enough databases already? And we're going to go over kind of what differentiates Gun and the kind of the controversy actually around what's going on in the database community. And then 5, how it works. So that's going to be much more of an architectural perspective. And 6, where to go from there. So that's just kind of a quick outline of what's going to go on. So first up, rather than blabbing to you about what Gun is, let's actually use Gun. So if you go to gun.js.org/think.html, it's going to be faster for you to build a to-do app with Gun to see what Gun is like than for me to try and explain it to you. So we need 3 things for this. We need a to-do app to have a UI, which since we're a web-based technology, we're using HTML. We need a way to interact with the user, and I've chosen to use jQuery just for simplicity's sake. You can use whatever framework that you want. And then third, we're going to use Gun to actually store the data. So the first thing that we have to do in this tutorial is to change the HTML. Just that way, there's familiarity with HTML. We're going to build this to-do app, and in order to do that, we have to pull in jQuery, Gun, in order to use those libraries. So we plop in those script tags, and we see that they loaded. So that's great. Now we want to actually interact with the user to get data from them, in which case we create a onSubmit handler with jQuery. So that way when a user types in data into the inputs over here, they can submit and get some data. So let's plop that code in. And we now have a submit handler with an alert message. So if I say, get groceries tomorrow, we get this nasty alert message with the data that the user had typed. But rather than doing an alert message, we're going to actually want to save the data because alerts are pretty annoying. So in order to do that, we have to instantiate Gun. We do that by saying var gun equals capital G Gun, the constructor, and we call it. Gun has a chaining API. So we're immediately able to chain off of this new Gun database and say get thoughts. What this is doing here is it's saying, hey, I want to get this key, because we want to read out the values from our thoughts or our to-do list, and we're also going to want to write to our thoughts or to-do list. So Gun, first off, is able to do key value stuff. But the way that we're going to use the value on this key is more like a table, okay? So let's go on to the next step. We drop in instantiating Gun. So now we have Gun. But now rather than alerting the message, we actually want to save the data to Gun. So the way that we do that is we say gun.set, and then the value that we want. And then we're also going to clear out the inputs. That way the user is able to type in another thought. So let's drop that in. And just for a demo here, I'm going to say get eggs. Now, when I hit enter, nothing's going to happen because I'm not reading the data yet. It vanished because we did the input.val set to empty, so that way a user can add another thoughts, like buy milk, okay? But where is this data going? How do we read it back out? Well, Gun is an event-driven database in the same way that JavaScript in the browser and Node.js are event-driven. So we can say gun.on, and .on subscribes to all changes to the current context of the chain. And the context of the chain was get thoughts. So it subscribes to all the changes to thoughts. And then we're going to say .map. For those of you who are familiar with like Haskell or Elm or functional programming languages, a .map is just another word for .for each. So what we're saying here is, hey, Gun, give me each record in the table and also give me the record when they update. And that's it. So let's plop that in. The rest of that is just jQuery to mingle the HTML into being there. And you note that our app already has the data displayed out there. So if I go ahead and add something here like broadcast to London.js, it immediately updates. So that's it. Hopefully that was less than 5 minutes. That's Gun to build a to-do app. Ridiculously simple, only about 15 lines of code. Now, we're not quite done yet because most to-do apps are going to want to delete data. So the way that you do that is you say gun.path, and what path does is it allows you to traverse into an individual record, okay? So we traverse into that record and then we put null on it, and null is going to remove that data. So when we click done, that pops that in. So just as a quick demo, if I double click on, you probably want to use a better interface than double click, but that's what I was using for the tutorial just for simplicity's sake. If I double click, that does a null event into Gun, which then the map function reacts to that null update. And then since our thought is null, since we just deleted it, we then wind up hiding that element. All right, so there you go. But Gun can do more than just a to-do app. So I'm not going to go through the next tutorial completely. You can do this on your own by just going to the website. But I want to show you really quickly how Gun makes that reactive synchronization work across browsers. So we're going to go into a demo chat app that is built on top of the to-do app. However, to save us time, I'm just going to copy and paste code in. Again, it's only about 20 lines of code. You can see that this view immediately updated with a bunch of junk data because people have been spamming the system with a bunch of stuff. But to see it update, and I hope that the demo gods don't blow up on me, I'm going to pull up the exact same app over here. I also have to paste in the chat app again into the editor. And once I get that pasted in, I should see the entire chat app. Oops, how do I scroll properly? Okay, let's scroll to the bottom of the chat message here. And I'm going to send a message from this incognito tab, if I can get these scrolling windows to scroll properly. Oh, I'm probably already at the bottom. Yeah, no. I'm going to send a chat message from incognito. Hey, send, and it updates on the other browser on the other screen. And this is running through a live example server. So there you go, real-time synchronization. And the code for that, like I showed you up here, let me full screen this back again, is fairly simple. We have a little model for our messages, and the lines of Gun required is, hey, we're going to instantiate Gun, but this time around, we're going to instantiate it with a server that we're going to synchronize through, which just happens to be another Gun peer. And then we're going to get the tutorial chat app. And then we're going to do the same thing that we did with the chat, with the to-do app. We're going to do gun.map.val. So .val is slightly different from .on. .on gives you all the updates. .val just gives it to you once. So that code there is pretty much the same from the to-do app. And then when somebody submits something to the chat app, we just do a gun.set message. And that's it. All right, jumping back. And I'm going to switch over to video again. So hopefully that was just a quick primer of what Gun is and how it works, and gets you a little bit excited about how easy it is to build a real-time chat app and stuff like that. But let's kind of zoom back. what about the blabbiness of Gun? Well, Gun is real time. As you saw, it's offline first, which is pretty cool. You can make those edits on your browser while you're offline. I'm gonna be giving a demo of this later. And then the changes will synchronize when you come back online with the server. And it's gonna handle conflict resolution for you. Gun is also peer-to-peer as well as a graph database. I'm gonna explore what these things mean a little bit later, because I want to first talk about why I built Gun with real-time, offline first, peer-to-peer graph approach. So story time. My previous startup was a collaborative web design tool, and because it was a app that would create a website, and a website is a document, I thought a document database would be the perfect fit for my app. That didn't work out so well for several reasons. First off, a website typically has pieces that show up in multiple different places. So a header shows up in multiple different places. A footer shows up in multiple different places. That's very relational. So you need to actually be able to store those elements independently and then relate to them, okay? The next piece was I wasn't able to sleep through the night because I would wake up some random night because I got an alert message saying that my server was down, and I would scour through everything, and I'm really bad at DevOps, by the way, trying to figure out what had happened. And the CDN would be working fine, right? Because that's not my responsibility. The front-end application would be working fine. My application server would be up and running, but the database crashed, okay? And even though everything else was working, data is the lifeblood of your app, and if you can't get access to that data, you're out of luck. So I had one too many sleepless nights where I was panicking because stuff was down. And I thought, no, it'd be really, really nice if I had a fault-tolerant browser that was offline first, a fault-tolerant database that was offline first, so that would work regardless of whether my server was on or not, or whether the database server was on or not. So I knocked out proof of concept where I had both relations and documents together, which allows you to basically do graphs. And I built the database in the browser itself with JavaScript, which is kind of a scary idea. But what that allowed me to do is, even if the server was down, at least the browser had a copy of the user's data on it. I'm gonna be giving a demo of that later. I posted this to Hacker News, and wow, I got a huge response. Homepage at Hacker News, and I realized, okay, there's something here that's more than just what I want. And I think it was because Firebase had started pioneering this, right? That having a database that syncs and does push for you, rather than having to constantly pull from the database and having all that complicated overhead and architecture to get those updates out of the database, it's just easier to have the database push them to you. So I think that's part of the response that helped propel this. And as a result, I then got accepted into a Bitcoin accelerator, Boost VC, out in San Francisco. And from there, wow, they did a great job. They connected me to some VCs, and I was able to raise money from Tim Draper, who's a billionaire out in California. I'm gonna take a quick side track to tell you the story of that. So I'm a technical person, and when I went into the first meeting with Tim, who's this billionaire, I could not explain what Gun did in any way, shape, or form that he understood. So I wasted this like 15 minutes worth of time. But at the very, very end, he was like, hey, would this be good for gaming? And I was like, no way. And he's like, oh, well, if it is, you should build a game called Gunslinger. I totally did not get that he was having a pun because I was so nervous talking to the billionaire. And I left the meeting and I was like, dang it, that was horrible. And a few hours later, I was like, wait a second. Gun actually would be really good for gaming. This guy's really a genius. So I had a subsequent meeting with them when we did demo day from Boost VC. And I knew I had to build the game that he suggested. So I knocked the game out in a few days, and then I practiced playing the game for like weeks on end. So that way, when I went into the second meeting with the billionaire, I had 5 minutes. I stepped in the room and said, hey, Tim, I built the game that you recommended. We're gonna play it. And if I win, you have to invest some money in my company. So he pulled out his phone, I pulled out my phone, we went to the webpage and played the game, and because I've been practicing for like 2 weeks straight, I had absurd human reflexes, like sub-100 millisecond reflexes, and won, of course. Now, he thought there was foul play, so I handed him my phone and he got to play against himself. That part was actually bad because I only had 5 minutes, and he started playing against himself for the next 3 minutes. And after 3 minutes is like, Tim, can we talk about like investment and the business side? And the moral of the story is that we didn't actually wind up finishing that discussion. So he said, oh, I'll email you if I'm interested. But the email never came through. So an entire week, I'm waiting to get an answer from this guy. And after a week, I'm thinking, okay, I blew it. I haven't gotten an answer. So I emailed the guy who runs the incubator and said, hey, have you heard anything from Tim about Gun? And the guy was like, no, haven't seen anything. And then I think it was like over the weekend or something like that. On Monday, the guy who runs the incubator said, oh, oops, I have like this $250,000 investment email from Tim Draper that was supposed to get sent to you, and I totally skipped over it. And I was like, how do you miss a email with that type of offer? And then I subsequently got Tim as a lead investor, and things have been great since. So I'm actually paid to be able to work on open source stuff, which is fantastic. So enough blabbing. We also wound up raising from some other VCs as well as another billionaire, Mark Benioff of Salesforce. So enough blabbing, back to the code side, okay. So how do we use these graphs? So it turns out that like graphs are actually like the next big thing. In fact, like DB Engines is saying that like there's 600% more interest in graph databases over any other database models. And you know, this new hype cycle that's coming up. But guess what? If you're using JavaScript, you're using graphs already. So for this, we're gonna jump over to an example of graphs with JavaScript. Not even Gun at this point, okay? Let's say I have var mark, and I have this object here, and I say first mark, last, nadal, email, mark at gundb.io. So we now have
Mark, we can't see your screen.
Oh, thank you. I forgot to switch it back over. Silly me. Thank you. Please remind me of that.
I'm here for that.
Okay. There we go. So we have just a regular old JavaScript object. I'm going to create another one called cat. First is Fluffy, and the species is going to be kitty. So I'm going to change species to kitty because obviously that's very scientific. And then Kitty doesn't have an email. However, Kitty does have a slave. The slave is Mark. So Mark and cat, right? And cat has a property of slave, which points to Mark. Now I'm going to say that actually this is getting a little crunched down here at the bottom. How do I? There we go. Actually, that might be a little too. Okay. So I'm now going to say that that mark.owner is equal to cat. So now we have mark.owner is the cat, and cat.slave is Mark, and mark.owner.slave is Mark again. So in JavaScript, you just have circular references. Now, if I wanted to now save this data to the server by sending it over AJAX, you would typically JSON.stringify it. But you've probably seen this before. If I happen to try and stringify Mark, ooh, we get this nasty circular error reference, which is super annoying. So most document databases can't handle this, and even relational databases, despite the fact their name of being relational, don't really handle circular references. But hey, if we're using Gun, this is just going to work out of the box. So I'm going to instantiate Gun. Okay. Then I'm going to say Gun. We're going to overwrite Gun with Gun. Actually, no. I'm going to say let's do gun.putMark.key and give Mark a key of human Mark. And there we go. So if I do now gun.get human mark.val function, val console.log val, we see that we get mark back, okay? But I can do something even cool. I can do gun.get human mark.path. Remember the path from the to-do tutorial? I'm gonna navigate into that property of owner, and I'm gonna do .val. And that's going to turn out to be cat field console.log, the cat field, and then cat. And there we go. We have fluffy species kitty. So that's illustrating kind of two sides of the equation. The key value, as you saw before, but now the relational side, right? That Mark can point to the cat and the cat can point to Mark. But what about the graph side? Well, the graph side really comes out with doing something crazy like this. Get human mark.path owner dot slave dot owner dot slave dot email dot val. And that is an asynchronous operation. It's just a utility. So even though it printed out, even though I didn't give it a callback, it was still asynchronous. And we get mark at gundb.io. Feel free to send me emails if you want. So there, you're able to have these documents that have circular references to each other. You're also able to have relations between different things. You can also do key value. In fact, we can say, hey, we don't want to have to always get to the cat by having to do get human mark path owner. We want to be able to access that node by itself. Node here as in like an object or a node in a graph. So we can key that directly with kitty fluffy. Okay. So now if I do gun.get kitty fluffy dot val, and then this is still asynchronous, it's just going to print out for me, I get the cat back. In fact, I can now navigate to mark through kitty fluffy by doing slave.val, right? So that's pretty cool. I can key pretty much anything, anywhere in the entire document. I can have the documents relate to any other documents or themselves and have circular references. But I can also have not only a key anywhere, but I can also have multiple keys on a single thing. So I can do get kitty fluffy, and I can put another key on that. Like, let's say, or actually, let's use the example of human/mark dot key. We know that my email was email/mark at gundb.io. So with gun, you can have a key value. You can have multiple keys that point to a single value. You can have well, I'm just repeating what I said earlier. You also saw from the to-do tutorial, and I'm going to switch back to, actually, no, not quite yet. You also saw from the to-do tutorial that we can kind of iterate over a list of items or a table. So Gun, because of graphs, allow you to be able to do any of these data structures. The next cool thing, though, is that these data structures allow you to do actually some pretty sweet stuff. So I'm going to show you a demo where we combine the peer-to-peer nature of Gun, the offline first nature of Gun, and data synchronization on the graph. So this is like the holy grail demo that I give to people. Let's do a real-time update on that hello world, if everybody can see this properly. So you get the real-time updates, like I was saying, so that's the real-time side. But this is getting passed through a server, which I'm running over here. I'm going to kill this server. So that means like your production server just went down. I'm gonna do something even worse. I'm gonna delete the data that I happen to have on the server. So I'm just gonna wipe that out. Boom, it's gone. So I'm now gonna go back to the peers and make conflicting updates while they're offline. This peer is gonna do A, and this guy is going to do B. So I'm gonna refresh both to prove that they're offline. This is your worst nightmare as a web developer because your server is down, you've lost all your data from your database, and guess what? Your users were on your site as it happened and made conflicting updates. Guess what? If we're using Gun, this is totally fine. So check this out. I'm gonna launch a new server, npm start, and I'm going to refresh this guy, and you see that the data recovered because Gun is JavaScript. It runs in the browser as well, and it stores a cache of the data there. And it's not just a cache, because Gun is fully peer-to-peer. And look, when this other peer came back online, the data also converged, okay? So now we're completely back up and running, even though we had a complete loss of everything. I personally am biased, but I think that's pretty awesome, because guess what? I get to sleep through the night. And sure, I'm gonna say I'm not a database expert, because I started this from doing a web design app. But I thought, hey, the current database I'm using cannot do what I want it to do. What if I just tried and built something better? And I argue, I feel like I've done, and I hope that that demo proves it. And this is kind of where the controversy starts, because the reason why I'm able to sleep through at night is because I have a gun underneath my pillow. So why that name Gun, okay? A couple things. Let me switch back to screen. First off, data is very sensitive, okay? We have Google and Facebook and now governments that are trying to eat up all of our data. You as an application developer have a huge responsibility when you're manipulating people's data, okay? Where you're storing it, what you're doing with it, how you're encrypting it. And I wanted a name that invokes this type of sensitivity to something that I feel like a lot of the tech industry may not really care about, especially here in the USA. We have all the scandals with NSA tracking all of our data. So your database is a weapon, and how you use it winds up being important. You shouldn't always use that weapon for anything and everything just because you can. So Gun, yes, is powerful and flexible, can do all these different things, but it is a tool that's in your hands, and you need to be careful with how you wield it. So that's just one aspect, okay? The second aspect is it's secretly a acronym. Don't tell anybody, even though this is a live publicly broadcast. Gun is an acronym for Graph Universe Node. Because it turns out, and actually, is it at this point? Okay, yes. So it turns out what I was showing you with graphs is that graphs from a mathematical side are a superstructure to both tables, which are matrices in mathematics, and documents, which are trees in mathematics. And because the graph is a superstructure of those things, it can do any of those formats, as I was demoing earlier. But not all trees or documents can have a graph, and not all tables can have a graph. So graphs are kind of what I'd argue the data structure that the universe itself runs off of. You can express essentially anything with a graph. In fact, most of your programming languages wind up converting to an AST underneath, which, despite the fact of it being an abstract syntax tree, is still represented as a graph because one part can call the other, so it's relational. So programming languages are Turing complete. Graphs are powerful. Anyways, getting back to kind of the controversy side, Gun's approach to not being able to recover from the server that crashed there, and it is only possible because Graph has a fully peer-to-peer, Gun has a fully peer-to-peer or decentralized or distributed approach to data. This flies in the face with a lot of the current databases out there, which are what's called master-slave databases, okay? Master-slave databases say that there is one database that is the owner of the data, that is a single source of truth. However, that quickly becomes a bottleneck when you're trying to scale up, because ultimately all of your writes have to go through this master. So Gun is taking the opposite approach, which is, despite the fact that, like, to me it's the obvious solution, it actually generates a lot of controversy. So I have actually had CEOs at competing startups like tell me I'm shooting myself in the foot for the architectural decisions I'm making with Gun, because the direction I'm going is, to me, obvious as a solution, but very against the grain. So the reason why it's against the grain is because the next point in this kind of controversy is that Gun is dethroning that master-slave database structure. Gun is dethroning the master. And when you remove the middleman, when you remove the centralized power, guess what? They typically get upset. And I don't mean, because when it comes to your database and infrastructure, there isn't really like this evil boss that's running, but there is such a analogy and tie here that's going on that yes, there is a war between these decentralized data structures, which is what the web was based on, and a lot of these walled gardens that are popping up. Now, I want to be very, very clear. You can use Gun in any of those scenarios. And the reason why is because if you start with a database that is fully peer-to-peer, you can do something like BitTorrent, okay? But you can also build on top of that and do something like email, which is federated. But you don't have to stop there. You can build on top of that and do something that is centralized. So no matter what your app is, whether it's a centralized app, whether you're building that next great walled garden, or whether you're trying to do the next BitTorrent or email, Gun is able to do all those scenarios. However, if you start with a database that is master-slave to begin with, you can only do a centralized app. You can't break back down into the federated or into the decentralized setting unless you wind up having some special protocol that winds up doing it for you, which then it is decentralized or peer-to-peer. So that flies in the face of a lot of stuff. And so they're kind of, what I'm trying to do is start this revolution in the database industry, saying, hey, we have better solutions now. We have better algorithms now. So part of that piece is then democratizing the database for the masses. And this goes back to my comment, if I'm not a database expert, but I feel like I've built something that is incredibly valuable because I do get to sleep through at night. I have gotten really upset historically where there would be a bunch of database posts on Hacker News or something like that. I'd go in and I'd comment like, oh, how does this work? And a lot of times the response that I get is that, oh, that's hard, leave it to the experts. And I'm not saying that there aren't people who spend a lot of time to solve these problems, but that attitude of being dismissive and leaving it to some authority unsettles me because, first off, it feels like it's great patronizing to me. But then the next thing is I then have this database that's a black box and I don't know what's going on. And then it crashes in the middle of the night and I don't know what happened. So I thought, okay, I did leave it to the quote database experts and I didn't get to sleep through the night. Why don't I try as what I'd argue just another JavaScript front-end developer like yourself, or if you guys do JavaScript on the back end, whatever it is, what if I tried to build a better solution? And I'm hoping from the demos I've shown you that you're convinced that there is something interesting here. So in that approach, I'm trying to say, hey, these databases don't need to be a black box. We can have open discussion about them. We can invite the community to partake and to comment and to critique and to contribute and ask those questions of how it works. And that leads directly into the next section, which is how does Gun work? So before I go over how Gun works specifically, I'm going to do a quick primer on why something called strong consistency, which is related to master-slave databases, are bad. And I have, let me check my time. Okay, let me switch over to screen share. I am going to pull up a couple slides for this because I'm going to try and attempt to explain these things in as layman of approach as I can. And that, and jump over into here. So conflict resolution with guns. Can people see this? Yes. Okay. So first off, we already talked about the controversy. What is decentralized? What is distributed? What is peer-to-peer? Well, at the end of the day, it is more of a physics problem than it is necessarily a programming problem. And here's the analogy. Let's say you have a restaurant and you get a ton of customers coming in and you have one chef. That chef has to process those requests serially, okay? And that winds up being pretty slow because one chef is bound by time. And guess what? This analogy here is to a CPU. A CPU in one sense is a chef, whether that be multiple CPUs on your one machine or multiple machines with multiple CPUs. So how can we make this better? Well, if we distribute the load over space, we can immediately double our revenue and half our time because we're able to serve customers in parallel. And also, so that's in terms of time, but we're also able to then have the second chef to deliver the extra ones, and that's the space side. So I think the restaurant analogy here is really fitting for kind of understanding distributed systems. You have chefs and you have customers that want food, and they have to serially process and make those food. However, this alone is not interesting because those two chefs could be competing restaurants. And if they're competing restaurants, they don't need to have any sort of cooperative communication between them. So we say that these distributed systems that don't have any coordination are uninteresting. So what we're interested in is a distributed system that has coordination. But as soon as you have coordination, you have to have communication between the chefs through space. And that leads to some problems. What if the chef dies? Now, the other chef, how is he going to recover from the failure? Well, a lot of people said, hey, we can solve this just by introducing a master. If we have some boss, then our chef employees don't have to coordinate with each other. They just receive commands directly from the master. And so then if the master sees that one of the chefs is dead, then the master just says, oh, let's have this other chef take on the load, and tells that chef the command. And people were like, wow, this is great. This solves all our problems. But no, because the same problem with the chef applies to the master. What if the master fails? You're kind of stuck in a bind. So how do we get around this? Well, we came up with something called leader election algorithms, where we said all the chefs are treated equally initially, and then we have some majoritative vote to elect who is going to be the master. And that allows you to withstand with four chefs, we're going to withstand any one failure. But we have this extra issue is we don't necessarily know that a chef that doesn't reply. So let's say Bob is upstairs and yells down to Alice downstairs, hey, Alice, do you have garlic? If Alice doesn't reply downstairs, you don't know if Alice is dead or if she's just serving the customers, right? So if she's serving the customers, she might be busy and therefore not able to reply to you. Okay, so this is a fundamental problem in distributed systems with coordination, is that when we're trying to talk to each other, if we don't get a response, we don't know if the chef is dead or if the network just failed. But the nice thing is with leader election, we can, with four chefs, handle any one failure, whether it's a network failure or whether it is a chef dying. And that works like this. If that one chef in the bottom right dies, well, the top three chefs can do a coordinated consensus vote to say who's the next leader. And this works in every permutation, okay? However, it doesn't work if you want to survive more than one failure. So the next step is, let's say we want to survive more than one failure. Well, we add more chefs, right? Kind of. But the problem gets a little sticky, because what if the network goes out straight down the middle? We now have three chefs on top, three chefs on bottom. There's a majority on each side. So what they would wind up doing, unless you program it differently, is automatically electing some master on both sides. However, this is then we're getting into some more of the mathematics side of database. This causes what's known as a split brain, okay? And this relates to something else, the CAP theorem, which states that you can either be strongly consistent, and you have to choose two of these three things, and or varying levels of these two of these three things, but it's much easy to think about it as two of the three. Your database can either have a globally consistent or strongly consistent view of the world, be highly available to your customers' needs, or survive these type of network outages. Most of the databases out there, as I mentioned, go for the master-slave approach, which is, generally speaking, a strongly consistent or globally consistent approach to the data. But if you do that, you cannot elect a leader on the both sides of these, because guess what? If after an hour the network actually reconnects, you're going to have two bosses. You're going to have two masters. And sure, maybe at that point you can then figure out which one will become the real master. But in the hour of being disconnected, they might have made conflicting commands. Therefore, your customers on the bottom half of the network and the customers on the top half of the network would be seeing different views of the world, which is, quote, violating this principle of strongly consistent systems. So as a result, if you want to go with these strongly consistent databases, this master-slave approach, guess what? You have to sit and wait and do nothing, ultimately, at the end of the day, until your network comes back online. And this not only sucks for you as a business, okay, it also sucks for your customer. Customer's not going to wait. There are workarounds, okay? People came up with Paxos and Raft. However, the thing with them is that the algorithms themselves are pretty complex, such that an independent reviewer, Kyle Kingsbury, also goes by AFER. You've probably heard of his Call Me Maybe Jepsen series. Has a bunch of jargon words where he analyzes a bunch of databases and cracks them apart. It turns out that just the mathematics of these algorithms are fairly hard to convert to the programming side, such that I think he reviewed only 1 or 2 of an underlying algorithms did it correctly, and that might have changed since. And then also, even if you have the underlying algorithm implemented correctly, in order for you to build your infrastructure on top of this, you have to be an expert at DevOps to know how to set up all the minimum requirements to match those algorithms, to have enough chefs in enough places with enough connections to be able to survive whatever level of failure that you want. And that's not a bad thing. It works, but at the end of the day, it goes back to this physics problem. It's trying to simulate stuff happening on one machine when you go beyond the limits of that one machine. And that's where physics starts to disagree with us. So I'm going to propose a very controversial idea. It's going back to the controversy, which is saying, say no to strongly consistent systems, say no to centralizations. And part of the physics reasoning is that, let's say we have 2 planets. Now, really, this is an analogy for when you go through the subway. When you go through the subway and you get disconnected for 4 to 20 minutes, because it turns out it takes light about 4 to 20 minutes to travel between Earth and Mars. You write that update on the subway, and you want to send that update out, and what's going to wind up happening is that the data is going to become desynchronized. And the reason why, I have a slide for this. Let's go over the physics really quickly. You probably heard of quantum mechanics. You're probably maybe more of an expert at it than I am. But here's a quick, again, synopsis of some of this stuff, which is this whole kind of review is trying to explain these things in layman terms. So I'm missing out on a lot of detail. So please send me corrections if you note anything. You have this really bad representation of an atom and the orbital levels of an electron around it. And let's say we have an electron orbital level 5. It will jump between orbital levels like 5 and 2. When it goes through that state change, it doesn't move through space, it teleports. It is a quantifiable difference in its orbital states. So from 5 to 2, that is -3. That quantifiable difference is the essence of quantum mechanics. That's what a photon is. That is what a quanta is. It is the point at which we cannot view motion through space, that it winds up jumping or teleporting. So what does this have to do with your app you're trying to build and all this stuff? Well, it means that at the end of the day, the universe is not strongly consistent. And the analogy here from the subatomic to now the macroscopic is that the light from Alpha Centauri takes multiple hundreds of millions of years to reach us on Earth. So when we see the light from Alpha Centauri, we're seeing an eventually consistent view of their state, which is several million years old. We're not seeing a globally or universally consistent view. So the point is that if the universe itself, if physics itself is not strongly consistent, what on earth are we doing trying to build databases that pretend like physics and data and storage is that way? You're fighting with the universe. So what do we then do? Because we still have this problem that I mentioned with the metro, which I didn't actually explain. I'm going to explain it now. And this is how it's going to relate to your app more. Is let's say Earth sends an update out. Let's go with the eventually consistent approach. It's going to lead to some problems as well. Okay, so eventually consistent systems are not the solution to everything. But here's the analogy. So Earth and Mars send an update out at the exact quote same time. So Earth sends out hello Mars, which takes 20 minutes to arrive at Mars, and Mars sends out hello Earth, which takes 20 minutes. What's going to wind up happening is that once the data is received on both ends, they're going to diverge because Mars is going to have the quote more recent update that it just received from Earth, even though it took 20 minutes to send it. Hello Earth, and same thing with Mars. They're out of sync, and that's problematic. So there have been other solutions like timestamps. Timestamps are bad though, because any client could set their local machine's clock to 2 years in the future, in which case the timestamp synchronization algorithm is going to wind up saying that that person's update wins for the next 2 years, which is going to prohibit you from writing to that data for 2 years, which is a terrible, terrible vulnerability. There's also vector clocks. Vector clocks was a better solutions, but they were invented in like the 70s or late 60s, I think 70s, and they require and back in the 70s, a physical server was fixed. Vector clocks required knowing a fixed number of peers in advance, but that doesn't really work in our elastic ephemeral environments of the cloud nowadays, because we might spin up 100 machines and then shut them down, and that doesn't work with vector clocks. This was just a quick explainer on how vector clocks work, but I'm going to skip over that. Basically, vector clocks are not very friendly because they don't accept new incoming peers. So do we have to go back to strong consistency, or can we do something better? So how does GUN work? What is the actual GUN side? The conflict resolution algorithm. Well, GUN treats all data not as data points, but as data intervals. And that data interval is expressed by a boundary function. And that might sound like complicated math, but it's not. It's just saying, let's go from 3 to 5, where we include 5 and exclude 3 directly. So we express data as this combination of a vector clock and a timestamp. And what that allows us to do is to divide the data in 3 different categories. We have the operating state, which you can think of that as being the state machine, the finite state machine. This is the actual state the machine is at this point. Then there is the historical state. Then there is the deferred state. You can also think of that as past state and future state. So what winds up happening is when GUN receives updates from different peers when it's running through the synchronization algorithm, it does the following. It says, hey, let's find out where the limits of the boundaries are. If we have an update, and I'm going to use just a simple integer of state 4 and state 8 here. If we have an update that says, hello Mars at state 9, GUN is just going to say, hey, this machine is not at that state yet. So we're going to process it later. And this gets around the timestamp problem where if somebody sets their machine clock to 2 years in the future, you're able to say, oh, that person's probably lying. So if they want their update to be applied 2 years in the future, then we will apply it 2 years in the future. We don't need to worry about it now. The issue is it's not always a vulnerability, because the way that your GPS works is it winds up receiving information from satellites. And satellites, because they're so far away from Earth's gravity well, are actually running at literally a different state in time from us because of Einstein's general relativity and special relativity. So there's actual scenarios where a machine that's claiming to be from the future might actually be from the future because of Einsteinian physics. Okay, so jumping on, then let's say we get an update of hello sun at a historical state of state 3. Well, guess what? We say, hey, let's record that to a journal if we have a journal, if we want to log data, if we want to save those old updates. But we're not going to merge it into our current view of the data. Well, now let's deal with the last case, which is what if we just receive an update that is inside of the boundary function, inside the limits of our operating state, of hello Venus state 5. Well, we do a comparison on the states and say, hey, 5 is larger than 4 and 5 is smaller than 8. And I should say it's 5 is smaller than and equal to 8, which is the filled in boundary, and 5 is larger, not equal to 4, which is the open boundary on the bottom, aka an open closed interval in math. We process it and that becomes the current view of data. But let's say then over time, this machine moves through, changes. Its boundaries are, sorry. So what that means is when we receive an update that is inside of this boundary, it becomes the new lower boundary. So it becomes the new lower boundary for that individual data record. All right, now arbitrarily over time, the state of the machine, the upper boundary is just going to increase, whether that be from time, whether that be from operations, you choose. This algorithm is kind of agnostic to it. However, GUN implements it from a timestamp plus vector clock combination. So let's say the upper boundary moves to state 9. And let me check on my time right now. I need to be wrapping up, but it's almost done. State 9, we wind up then saying, hey, I remember that we had an update that was deferred that was supposed to be applied to state 9. So because we've now reached state 9, we can now process this request. In which case, the same thing that happened before, the lower boundary now snaps to this. So those close. Now we're going to deal with a final edge case of how the conflict resolution algorithm in Gun works. And this is getting really nitty-gritty detail. So this video is divided into sections. Hopefully people will be able to skip between things as well. For the live view, you're kind of stuck with me for now. Let's say the upper boundary arbitrarily increases over time. So let's say state 12, and we then receive an update of Hello Mars at exactly the lower boundary because it's open. We have a conflict. In which case, Gun winds up choosing something very, very naive. It first says, let's check if the states are equal, potentially the values are equal. And if the values are equal, well, it doesn't matter which update wins because they're the exact same value. However, if they're different, we do something naive. We look for their lexical comparison. We lexically compare them alphanumerically. And that seems kind of stupid, but the point of this is to have a deterministic algorithm that will work on every single machine anywhere in the universe such that data is going to eventually converge to a consistent view. So that is kind of what Gun is doing, and that's in the future going to be something you can potentially swap out. But right now, it's sensible defaults and just works for the majority of your apps. So let's go back to, and the result, we don't lose that previous update. It just gets bumped to the lower boundary, okay? And then potentially pushed into the log or the journal if you have it. So that was very, very abstract. Let's jump back to that original analogy, okay? What winds up happening is Earth winds up sending the update out to Mars, and it takes 20 minutes for that update to occur. However, Mars winds up sending that update at the same time that Earth did out to Earth, they quote exact same time, but they're still going to converge to the exact view because not only on the vector and the timestamp and the lexical ordering, it's all deterministic. So that's how Gun works at a very low level in terms of the synchronization algorithm. Although do note that that convergence is eventually consistent. So there are a bunch of edge cases to Gun. I'm not saying Gun is a silver bullet to solve everything. In fact, I'm not going to go over the rest of the slides here because I'm pretty much done. The batteries not included side of Gun says that, hey, stop screen sharing. If you want to do like a banking application, you probably shouldn't use Gun, although there are algorithms that exist. If you want to do something like Git, where you have a dependency chain of data, well, guess what? Gun's actually a good algorithm for that. Gun isn't a good algorithm. You can build Git on top of Gun. And the reason why that's the case is because Git itself is a distributed or decentralized or peer-to-peer algorithm. So if you want to do these higher level of data guarantees, don't rely upon some black box magic of a database. Understand what's going on in the system, and then have sensible defaults, which Gun says, hey, let's just sync things with these vector clock, timestamps, lexical resolution, which should work for most stuff. But if you then have specific business applications that you want to build on top, whether that be linked lists or directed acyclical graphs, which is Gun, or CRDTs, for if you, which are conflict-free replicated data types, if you want to do like counting, there's algorithms that exist, and we're also going to be building those as modules and extensions that go on top of Gun. And then you choose piece, part, node philosophy, and pull it into Gun. We don't have those yet, but that's coming. So my argument here is that centralized systems have this fundamental bottleneck that violate the physics of the universe. So instead, let's find better algorithms, explain them to people, have sensible defaults, and then if you have higher level needs of that data, you then use some specialized algorithm that you then plug in on top. That's very much the Unix or Node.js philosophy of being extensible and reusable and modular. All right, that is pretty much it. So Gun's not the solution for everything, but it's sensible defaults for most things. Don't use it for banking. And for other more complicated stuff, send us emails and we can help make sure that we get modules dedicated to your specific use case. So now we're going to end with just the last note is that we're about to release a brand new version of Gun, which is 0.3. It actually has some breaking changes from 0.2.5, so just be warned in advance that a couple things are going to be modifying. However, don't let that stop you from diving in, because the more people that dive in and try it out is going to help us with the feedback cycle. The thing on the breaking changes, though, is that the current version that's in master, or that npm installs, so if you go ahead and npm install Gun right now, you're going to get the older version, and there's quite a few known bugs in it. So if you encounter any problem or any weird thing at all, literally just jump on one of these links. Particularly, the best thing for me is the Gitter, which is gitter.im/amark/gun, and send us a message, and we'll try and respond as quickly as possible. You're like, oh yeah, sorry, that's a bug. That's going to be fixed in the 0.3 release that we're going to hopefully have out in the next week or something like that. Overall, there are the links for you. Oh wait, I'm in video mode. I need to go back to share mode. There are the links for you. Gundb.io is a brand new website we just released for the enterprise side of things. You're probably going to be more interested in gun.js.org, which is more developer focused. But realistically, you're a developer, you're going to want to hit the GitHub. So just hit the GitHub. There are some docs in the wiki. We really need to add a lot more docs. A lot of this stuff is coming in improvement, but your feedback will help us with getting the right content out to you that can be helpful. And then please join the Gitter. There's tons of chats that are happening back and forth about all sorts of fun things, distributed systems, peer-to-peer stuff, gun stuff, of course, but not just gun stuff. And then any questions, shoot me an email. I'm more than happy to reply and even get on a Skype with you and sit down and help code whatever you're working on. All right, thank you. It's been wonderful.
Oh, thank you very much, Mark. This talk was absolutely brilliant. I really liked it a lot.
Thank you.
Thank you a lot for your time. I know that you are in the other part of the world, but honestly, I really like this talk. I hope that guys, you liked as well. So we will have another webinar quite soon in the beginning of February, and we will have also the 3rd of February a Redux meetup. It's a live meetup. Where we are going to introduce Redux. You can find all the details on our meetup page. So I think in I don't know, an hour or so, probably less, we will have this webinar on YouTube on our official page. So feel free to check it and share on Twitter and all your social, or the social that you prefer. And again, thank you again, Mark. I hope to see you soon. I don't know, when you want, you will be more than welcome in this community.
Maybe at another one of your events, hopefully in person in London.
Yeah, why not? I would really like have you here. So thank you again, and have a nice evening, guys. See ya.